All right, hello everyone. So what we're gonna start talking about now is a few kind of more advanced topics relevant to multiple regression modeling. What we're gonna start out with is modeling with categorical predictor variables. And so that will be the topic of this video as well as the next couple of videos, just discussing kind of what's different if one of our predictors is categorical. Up to now, we have only dealt with predictors that are quantitative. And so it's really not too different to incorporate a categorical predictor into a multiple regression model, but there are some kind of things that we'll need to address. And so what we're going to work with is this Wines data set. And so our response variable is going to be a wine quality. And so these wines were tested for wine quality among professionals, apparently, or whoever professional wine tasters really are. And a bunch of other variables about the wines were also measured. We'll look into this data set a lot more in a couple weeks, but for now we're just going to focus on the percent chlorides as a quantitative predictor and the type of wine, either red or white, as a categorical predictor. So chlorides is quantitative, wine type, either red or white. We're not considering pink or rosé or anything like that, just red and white. As types of wine. So that is going to be our candidate categorical predictor. Our first option for fitting a model with this wine quality as the response is to just kind of ignore wine type and just use chlorides. And so that's given in this graph on the next page. It's just a simple linear regression graph. We've been fitting almost this entire time, and so nothing really new here. The next option is to incorporate wine type in our fitted model, and to allow the two different wine types to have different intercepts. And so that's given in the second graph here. What this is doing is allowing for like a fixed value of chlorides. So maybe I'm just going to pick 0.7 as a fixed value of this chlorides variable. It's allowing the predicted wine quality to be different for red and white wine. In this example, it's allowing the red wine quality to be predicted higher than the white wine quality for a fixed level of this chlorides predictor. Our final option is to also include chlorides and wine type, but this time to allow for these lines to not actually be parallel and to allow them to have different slopes. Graphically, this we've actually already seen in ggplot2 when we colored by a particular categorical variable. By default, ggplot2 for geom smooth will make these non-parallel lines. Now we're allowing the red and white wines to not only have different intercepts, but to also have different slopes. And in this case, we're seeing the red wine slope is relatively flat, while the white wine slope is a lot more negative. Okay, so hopefully that kind of setup is pretty clear. I think looking at the models graphically is fairly intuitive. So just single line ignoring wine type, parallel lines so that the two wine types can have different intercepts, but they have to have the same exact slope, and non-parallel lines to allow the two wine types to have both different intercepts as well as different slopes. Looking at it graphically, hopefully it kind of makes sense. What we're going to do next is try to translate these graphical models into some models using statistical notation so that we could better interpret the different coefficients that are going to be estimated and then output when we actually fit these models in R. So again, the next goal is to kind of translate what we're seeing graphically into some model equations.